where everything we once imagined unfolds before us. Welcome everyone to Vibe in Action. We're joined again today by Peter and Professor Nam-shik. Great to have you both.
Great to be back.
Yeah, great to be back as well.
Isn't it wonderful that we're learning from such a world-renowned professor? I'm learning so much every week thanks to Vibe in Action.
Cambridge and Yonsei,
Yeah.
having both of those
Without
at the
any
same time.
tuition. Well, to be honest, I was not so much of a science kid when I was younger. I never dreamed of becoming a scientist like you. But I loved watching those sci-fi movies growing up, especially when I watched the time-traveling machines or the invisibility cloaks.
Oh, they're fantastic.
I wished, wow, it'll be so cool if I could travel like that.
Yeah.
What about you, Peter? We grew up in the same generation.
Yeah.
Did you enjoy watching those science fiction stuff?
Like, I'm not that old that I watched Star Wars when it first came out, but I remember watching it in the 80s and 90s and thinking, what would it be like to be on a spaceship? I wonder if it was the same for you, Professor.
Oh, why not? I was watching a lot of those movies, and also I dreamed to become a scientist.
Oh, wow. Dreams come true.
Dreams come true.
Yeah.
Indeed.
And is today's topic going to be related to sci-fi movies?
Nowadays, surprisingly, quite a lot of aspects in those scientific movies are now become to the real life.
Wow.
Oh,
And actually, this is really a good example, and actually, this is really ties into today's topic.
Oh,
Wow.
we're going to see Darth Vader in real life.
and lightsabers. Yoda once said, you should do or do not. There is no try.
Oh, he's
So-
wise.
Why don't we do it together?
Vibe in action.
Wow, what did I just see? Robots exploring inside the human body. Is this the topic we're going to discuss today that you mentioned?
Exactly, that's right. Of course, there are small aspects that we still need to overcome, of course. However, a lot of kind of fundamentals are now close to the reality.
I can't get my head around that. That's like a movie, right? Robots inside the human body. I have watched that movie, I'm sure. Like, there's one from the 80s.
Yeah, it was Stephen King or...
Yeah, there's got to be
who was
horror
it?
movies as well. But how far has the technology actually come, Professor?
Actually, we move far away beyond to the showing the fundamental concepts, but we are at the stage where actually the researchers can control very precisely of those micro or nanorobots.
Wow.
We are now really, literally, towards to the reality.
Unbelievable.
Are you sure?
I'm sure. I will show you.
Are you saying that these tiny little devices can actually crawl through my body like a bug?
Wow.
First of all, I am not 100% comfortable. I feel kind of itchy and weird
Yeah.
whenever I think about it. And second of all, I'm thinking, don't we already have some advanced tools like endoscopes and surgical robots? Aside from being extra smaller, what makes these in-body robots different?
Yeah, I mean, this is a fair point. And then conventional endoscope and other kind of so-called surgical robot or units, they are actually running outside from the body, not from inside. However, this microbot literally traveling through your veins and small part of your body. So they actually, it really measure and sees how your body changing. So that means it can do the diagnostics and delivering therapies at the same time.
Wow.
What happened to them after they finish their work? How do they come out of our
They
body?
live in there forever.
Yeah.
So,
Do I have to live with it forever?
I mean, this is a really important question as this small, whatever robot, or nanorobot, microbot coming out of the body, very first priority is a safety. So actually, researchers are studying about this too. So we can hopefully degrade themselves in a body without any tox.
Wow.
Or we can have some kind of retrieval system as well.
So they're
we
still
can just
working
spit
on
it
that.
out
That sounds
inside
uncomfortable.
a toilet.
No, AI will help you that the small things come out from your body safely.
Oh, nice.
After
Maybe when you're
you've done-
sleeping or
Well, you
something.
can't even check if it's out or not because it's too small.
You're very suspicious, aren't you? You're going to think they're still
I just
inside.
want to know the technology behind everything.
Yeah, but I guess we could think of it more easily like maybe endoscopes and surgical robots. They're like main buses on the main roads. And then the micro-robots, they're like the little village buses that go in the alleyways. Is that
Or
okay?
kickboards.
Ah, yeah,
Even
you hop on one of
smaller.
those.
Yeah.
It's a perfect analogy. And I think you are the good student.
We're learning well.
To be honest, I pride myself in knowing a thing or two about medical technology because I've been hosting a medical talk show
Sure.
with the best and the brightest doctors in Korea. So I've seen the likes of like gamma knife, heavy ion therapy, or robot arms, but I haven't yet seen or heard about micro-robots, not working from outside, but entering the body of a patient to diagnose or treat illness directly. Is this really happening right now? What are some of the examples that are already in place, that are clinically ready or already used in hospitals?
I think there are a few good examples, but the very first one would be so-called capsule endoscope, which is just like a pill, so you can just swallow, and then it will also check all of the things in your body. And also there is a wired microbots that can actually travel through your vein, and then that can monitor the changes in your body. And probably also there is a smart catheter that popularly used in the cardiovascular surgery operation
catheter.
rooms. Yes,
Catheter.
And that's a micro-robot.
that's my
Wow.
microbot.
Yeah, I've seen those robots pop up on my feed as well, but I thought that was just some cool tech. It can actually be used in medicine as well.
Yeah, exactly. They are not just like a viral videos anymore.
Not
It's
AI generated.
No, maybe some, but actually the truth is this is the future of the medicine.
They are like a living microorganism moving freely on its own, even breaking through barriers. And they're so teeny tiny and fascinating. But is it true that there's an even more minuscule world of technology beyond that?
That's right. Nanorobots.
Nano.
Even smaller than micro-robots.
Wow, but yeah, when we talk about something really small, we maybe attach nano to it, but it's really hard to grasp how small that is because micro is very small already. So how small is nano?
I can't even fathom. We need to understand the scale first. How about we compare it to a human hair?
Oh,
How small is it?
So that's good comparison probably. One human hair is usually 50 to 100 micrometers. And if you chop it down to 1,000 pieces, then it's gonna be 1 nanometer. So that means 1 nanometer means 100,000th of thick. That's the size of the nanorobot we are talking about.
What?
It's
A
a
thousandth?
mind-bogglingly small world.
so if you split one hair into 1,000, that would be a nanobot.
Yep.
You couldn't see
No, no,
that
no.
then.
If you split a hair into 50,000, hair
50
is already
to 100,000th. Yeah.
Oh, 1/50,000th.
hair is already 50 to 100 times thicker than
even
a
smaller.
micro.
Even smaller, much smaller.
What? I was uncomfortable at 1,000th, but a 50,000th.
50,000 to 100,000.
Yes.
You'd lose it so easily, right? And you can't see it with your eyes Of course not, right?
Of course, we cannot see by our naked eye, so we have very special equipment to see and monitor these small frames.
Ah, really? And you need that equipment to check it, that it's there?
Nowadays, we all have it.
Oh, wow. So it's
What do you
like...
call that?
Electron microscopies, and there are some other fancy tools that we can measure.
And you don't have to have a set of good eyes.
I think your eye can see the monitor.
You can check on the monitor via
Exactly.
the tank. Well, at that point, it really is like Hollywood movies. I remember watching Ant-Man, Quantum Mania, and they're going down into like the quantum realm. So it's that small.
It's that small. This nanotechnology is actually much closer to our daily life. Can you guess where we are using
I have
this
no
now?
idea.
Already?
Even
Already?
if the nanotechnology exists around me, how would I be able to recognize it?
It's too small.
How do I notice it?
I did see in the toy shop for my kids, there's nanobots, but they're about this big, so
That
that's
is
not
not
nano.
nano.
No.
That's
Yeah,
a
it's not
centimeter
nano.
bot.
But in our daily life, actually, I think you put sun creams on your face almost every day.
In
Yeah,
Korea.
sunscreen.
Yeah. And in the sun cream, the material called titanium dioxide nanoparticles that actually blocked the UV rays. So this is a fundamental material for our sun creams. Not even in the sun creams, but on your cars, it has beautiful colors, right?
Yeah.
So paint. So there is a special coating called ceramic glaze. So that using the nanoparticles as well. And also when you unfortunately go to the hospital and then take the MRI, you can take the special material to take it. So that also contains some of the nanoparticles inside.
All these are cases of nano-level technology,
Nano-level
not
technology,
micro-level technology.
Wow.
But whenever I think of something that small, I can only think of the allergen. I hate it. So maybe in the future, this nanotechnology can help get rid of all those allergen like pollen, dust mites, or pet dander.
Yeah,
'Cause
in the future.
I'm suffering so much.
Yeah, I got terrible hay fever as well. I didn't even think of that. But it's unbelievable that it's already out there in the world. Not nanorobots, but nanotechnology.
But my question is, unlike those sunscreen or ceramic glazing that you can just put onto something, nanorobots or nanobots need to be operated, controlled, or engineered. How do you do that? Who takes care of the
Like operation,
the
right?
operation of the bots?
So that's where we need kind of physical AI. So let's imagine nowadays we have a some cars having the autonomous driving machine. So we wanted to have this same system in a nanorobot.
Wow.
So it autonomously working around in the cell and then find the cancer cells and approaching it and then deliver the real treatment.
What are they made of, those nanobots?
Special materials.
Everything is
under
special.
wraps.
Can you be more specific?
No, you can't reveal all the secrets on here.
When you say robots, I can only think of those metals or plastics that
Yeah,
are
like
plugged
this
in
kind of
or powered by batteries.
Yeah.
But they're just organic?
They're organic. They're organic, of course. Nowadays, some of the researchers study about how can actually they move by themselves. So we cannot put some kind of engine or motors in a small scale.
Sure.
I think in your childhood, I think you kind of do a lot of origami style things with the papers. So we are now making kind of this kind of DNA origami, which means it actually moves by itself and then moving around inside of the cells.
But origami is not self-autonomous.
I guess if you fold it in a certain way, it kind of unfolds by itself.
Like a
why-
pop-up
where we-
book?
Yeah, that's where
Wow.
we need to put the AI inside of it.
That's amazing. So they're going to be finding the cancer cells, hopefully, and like taking them out, like little snipers,
Little
that kind of
snipers.
thing. Automatic snipers that might degrade as well. But the key difference between micro-robots then and nanobots, just the size, or?
Yes, I think they're essentially it's the size. So as you give some good analogy, but the microbots, I think is kind of the KTX or kind of big buses going between the cities in a highway. But as you said, kind of nanorobot is kind of quick boat or kind of small motorbike that going around the small kind of streets. So actually what we need for the precision medicine, we need to also deliver the kind of, for example, cancer therapy to a kind of exact location, the tumor cells. Then any other normal healthy cells. So that's what we can deliver.
And that's where you need the nano tech.
Yes.
They really do sound like the most incredible medical marvels. Really sounds too good to be true,
Nearly, yeah.
to be frank. If it works the way it's designed to work, then this should be one of the most powerful tools humanity will ever create. And it's a beacon of hope for many people. I mean, medical nanorobots will be able to help so many people cure their diseases, particularly those suffering from cancer.
Yeah, because with cancer treatment like chemotherapy, that targets just the whole body, so you just get really weak and lethargic. But with nanorobots, we're saying they can target just the areas that need treatment.
Yeah, exactly. These kind of cancer therapies, particularly the chemotherapies, is kind of the carpet bombing onto your whole body. So there is a high side effect.
Yes.
However, if you're using nanorobots, you can actually have your very smart bombs that exactly targeting the bad cells only. So this is gonna be the immense hope for the cancer patients. And we also using this for the so-called hard to reach regions, for example, brain. So there is a brain barrier, which quite difficult to send some drugs to cure Alzheimer's, for example. So we can actually using this nanoparticle to do this job for us.
Wow, I want to make a call to my parents again.
Hang on a little longer.
What a medical wonder. There's absolutely no limit to technological advancement. If you take a look, the market is already expanding with a growing demand. According to market research from DataBridge, the global nano-robotics market is expected to grow from about $10.9 billion in 2024 to $27.5 billion by 2032. And this all goes to suggest that this is a proven science, not just a promise.
Yeah, that's a huge market, right? So competition must be intense between countries as well. So which countries are leading the race at the moment?
So right now, the US and Germany and Switzerland take the lead with their very advanced technology. However, China is really catching up fastly. They're putting real astronomical investment from the state fund.
Wow.
The countries you just mentioned, the US, Germany, and Switzerland, they do have a solid history in the precision technology field. What about Korea? Where does Korea stand in this emerging field of high precision medicine? Shall we take a closer look?
Yes.
Ready, set,
Five in action.
A forward base for K-Medical robots turning imagined treatments into reality. The Korea Institute of Medical Micro-robotics. Starting with micro-robots for vascular treatment, in 2013, it developed the world's first bacteria-based nanorobot, proving the limitless potential of medical robotics in reality.
세계적으로 다른 기관하고 차이점은 첨단 기술과 원천 기술뿐만 아니라 실제로 인체에 적용하려는 상용까지를 우리가 하는데 거기에서 저희가 세계적으로 가장 우수입니다. 예를 들어서 이 건물은 R&D를 위주로 하고요. 비즈 건물에 가면은 그 R&D에서 넘어서서 시험평가하고 동물실험까지 거기서 사육을 하고 그렇게 하고 있습니다.
The Korea Institute of Medical Micro-robotics has a full cycle support system, covering everything from basic research to commercialization. As a result, its micro-medical robots continue to evolve. Capsule endoscopes have also progressed beyond simple imaging into third-generation multifunctional models capable of real-time tissue sampling.
현재 3세대 같은 경우는 동물의 장기를 외부로 가져와서 실험을 진행하는 엑스비보 실험까지는 완료를 했고 그 상황에서 생검 기능을 구현까지는 했습니다. 2세대 먼저 현재 인허가 진행 중이고 이어서 이제 3세대도 인허가를 받을 예정으로 진행되고 있습니다.
Another key achievement is the magnetically controlled catheter robot. which has dramatically improved procedural accuracy. Procedures that once relied on the hands of a skilled doctor have now evolved into a precise remote control system using external magnetic fields. Technological advancement is now expanding into the ultramicroscopic nano domain. Using ultra-precision 3D printing, robots are created at the nanometer scale, and advanced microscopes push process precision to the extreme. These nanorobots can selectively target cancer cells without damaging healthy tissue.
항암 약물에 암세포의 타겟으로 하는 마커를 이제 붙이거든요. 붙인 약물을 나노로봇에 담질합니다. 그 로봇을 생체 내에 주입을 하게 되면 그 마커를 찾아가게 되는데 그 부위의 초음파 구동을 통해서 약물이 훨씬 더 많이 집속될 수 있도록 치료 연구를 하고 있습니다. 쉽게 얘기를 하면 열쇠랑 자물쇠가 있으면 각자 맞는 열쇠가 있듯이 그것도 비슷한 원리라고 보시면 됩니다.
To keep nanorobots from losing their way in complex blood vessels with strong blood flow, ultrasound pressure and real-time tracking technologies are integrated. Like a precise navigation system, it guides the robot accurately to its target, cancer cells. Finally, the Institute's full-cycle support system proves its value once again. Through animal testing, the research team observes the robot's movement in human-like conditions and secures data at a level ready for clinical application.
특히 체내에 직접 주입하게 되는 의료로봇은 일반 의료기기보다 규제 난이도가 훨씬 높은데요. 식약처 인허가나 임상시험 진입을 위해서는 체계적인 전임탕 데이터 확보가 중요합니다. 의료진과 기업체 전문가들이 함께 참여하는 협력 체계를 구성해서 기술적인 난이도뿐만 아니라 규제나 상용화 같은 장벽까지도 함께 해결해 나가겠습니다.
Behind these innovations moving beyond the lab into reality is strong support at the national level. Large-scale national projects and bold infrastructure investments were carried out, with research institutes, companies, and hospitals working closely as one team.
의료기기 간편성이 더 중요해지는데요. 그 간편성 면에서는 또 마이크로로봇이 또 상당히 강점이 강하죠. 그런 점에서 마이크로 의료로봇은 의료기의 전체 패러다임, 향후 발전 패러다임에 딱 맞는 얼티밋 골 내지는 가는 방향으로 저희들은 정확히 보고 있습니다.
From micro to nano, a new medical paradigm shaped by tiny robots. The era of medical robotics, led by Korea, is bringing a healthier future closer.
Wow, that was honestly incredible. I had no idea Korea was that far along its own journey.
Well, given the fact that Korea is already a global powerhouse when it comes to medicine and medical technology, it only makes sense that Korea has a competitive edge in this burgeoning sector of nanomedicine as well. Because Korea has already got a fertile soil for that, with all the necessary sensors, semiconductors, and biotech and talented leaders like yourself already in place. Isn't it right, Professor?
Yeah, that's exactly correct. Your guess is spot on. As you know, nanorobotics is kind of ultimate version of convergence of all those advancing technologies together. So it does need, as you said, semiconductor level kind of manufacturing, AI, quantum. As you know, since Korea is a powerhouse of semiconductor, and also now we are becoming one of the leader in AI space. So Korea is having a very good position to dominate this new emerging field.
Yeah, fingers crossed, right? For nanorobots or nanorobotics to advance further, what are the challenges that still lie ahead?
That's a really good question. As we touched on earlier, the most important thing is that we really need to guarantee this safety. Because this nanorobot and micro-robot coming into our body, so we have to guarantee that it has a perfect safety. So now researchers already develop a few good mechanisms. For example, we already have self-degrading mechanism for these small robots, or we actually have a kind of real trace and track mechanism for this nanorobot. So after it has done its own job, we can actually have a perfect retrieval of this small nanorobot.
Well,
That's important.
While challenges and limitations remain for nanorobots, I can tell progress is accelerating like never before. And I'm really excited to see how they develop over the next couple of years. Peter, it's been another hopeful conversation.
Yes.
And another true vibe in action moment, right?
Yeah, and in hospitals, I can imagine in the future, instead of like pass the scalpel, they'll be like deploy the nano fleet. And there'll be like an admiral in the Navy or something.
Totally possible, and the voice who makes that order may not even be a human.
It might not be, wow.
Well, it's been so fun imagining all the possibilities. Thanks for watching, and we'll be back with more remarkable stories next time. All together,
Vibe in action. Bye-bye.
Bye. Actually, we've got no time because we're all aging right now, even as we speak. Why do we age?
We all know you shouldn't drink, smoke, eat junk food, avoid exercise. That all accelerates aging, no?
One of them is a senescence cell. So we have to know how to get rid of them from the tissue so that we can stay healthy.
Wow.
Like the one moldy strawberry corrupts the entire bowl.
Don't give me your senescent cells.
We translate it to human, it may mean that we can live up to 800 years.
Really?